Kia ora 13MCA. This question's for Sahisnu, and it's very, very, very similar to question 9 in exercise 10A, but because of copyright, I've changed the context and some numbers. So we've got a random variable x, and it's got this probability distribution. So the most important thing is that when x is between 0 and 7, the probability density function is given by this function here. Otherwise, it's 0. So if you picture that, what we've got is we've got some kind of upside down parabola thing like this. And we have to figure out, first of all, what C is. And we have to find that so that the area under that whole curve is equal to 1. And next we're told that a torch battery lifetime has got this distribution. And we've got a torch that's got 2 batteries, and the failures of those batteries are independent, which seems like a pretty reasonable assumption, right? So first we have to find the probability that neither battery fails in the first 2 years, and then we have to find the probability that exactly one battery fails in the first 2 years. Now actually that question there should say, I just want to change that in the first, make that in the first 1 year. Okay, just to make the question a little bit different. But the basic idea here is that we're going to figure out the C value, and then we're going to find the probabilities as follows. So the probability that a battery lasts for more than 1 year is equal to 1 minus the probability that it fails in that first year, right? We're pretty loose with whether this is a strict or a weak inequality because I'm working with a continuous distribution. So if we want the probability that we've got 2 batteries and one fails in the first 1 year, we can think about this as a tree diagram. So here's battery 1, and it either fails in that first year or it doesn't. And here's battery 2, and it either fails or it doesn't. Right? So for the first question here, we're looking at the probability of failure in the first 1 year. So that's going to be the integral from 1 to 0. And if we want neither battery failing, then we want this path of the tree, right? So I'm going to go through this more slowly in a second, but this is to start you off. So we want the first battery doesn't fail times by the probability that the second battery doesn't fail. And this is easy because those two things are independent. Okay, and then for the probability that exactly one battery fails in the first 2 years, we're going to have a tree diagram. The numbers in this tree diagram will be different because we're talking about failure in the first 2 years. But the probability that exactly one battery fails in the first 2 years is either that we have the first one fails and the second one doesn't, or this one doesn't fail and then does fail. Right, so now I'm going to work through that slowly, but that's going to be my basic strategy. And Sahisnu, that may well be enough to get you right through to the question, but please, please, can you watch all the way to the end? Okay, so the first thing we've got to do is find this value of C up here. Well, we know that the area under the curve is given by this. So we can pull the C out the front, and I'm going to expand these brackets. So I've got 7x minus x squared dx. Here, this anti-differentiates to give me 7 over 2 x squared minus 1/3 x cubed. Now I have to evaluate that at those limits. So that gives me C times 7 over 2 times 7 squared minus 1/3 times 7 cubed minus 0 minus 0. Always be careful of that bottom limit. Okay, so cleaning that up, I did this by hand because I didn't have my calculator right next to me. You can do that with your calculator, but you can see that we want the answer as a fraction. So what I'm going to do here is I'm going to get a common denominator straight away. So the common denominator is going to be 6. And I've got 7 cubed here, so it's going to be 3 times 7 cubed minus 2 times 7 cubed, right? So that's just year 9 fractions with worse numbers. So that equals C times 7 cubed over 6, and 7 cubed is 343. So we've got 343 over 6c. Well, what do we know? Well, that area has to equal 1. So 1 is equal to 343 over 6c. So c is equal to 6 over 343. So that's the first part done. Okay, so find what c is. Now, the next part is this part about the torch batteries, and we want to figure out the probability that neither battery fails in the first 2 years. Let's clean this up a bit. Okay, so the probability that the battery fails in the first year is the probability that the life of the battery is between 0 and 1. So the probability that it fails in the first year is equal to this. It's the integral from 1 to 0 of 6 over 343 times 7x minus x squared dx. So working that through, take the constant out the front, so 6 over 343. And then I've got, so 7 over 2 x squared minus 1/3 x cubed between 1 and 0. So that's 6 over 343 times 7 over 2 minus 1/3. Right, chugging that through gives me 6 over 343 times 21 minus 2 over 6. So that gives me 19 over 343. So you can see that that's going to be, that's the probability of fail within 1 year. And we want the probability, going back to that question, that neither fails in the first 1 year. So again, thinking about that, if the probability that it fails within 1 year is that, then the probability that it doesn't must equal 324 over 343. So the probability that neither fails, assuming they're independent, is just going to be 324 over 343 squared, right? So I've got a tree diagram, I've got this branch of it, doesn't fail, and then the next one doesn't fail again. So my final answer there I got was 0.8922. Right, that's obviously not going to match the textbook, but that's exactly the same type of problem as the one that you were asking about. Now the next one is the probability that exactly 1 fails within 2 years. First thing I've got to do is go back and work out the probability of failure within 2 years. So probability fail within 2 is equal to the integral from 2 to 0 of my PDF. This is getting pretty familiar by now. So this gives us 6 over 343 times this integral, limits this time are 2 and still 0. So when you work that through, I'm going to skip this next step because I'm sure you've got this down by now, but you get 6 over 343 times, what do we get? Well, we get 34 over 3, which gives us 68 over 343 as a fraction, which is roughly 0.19825. So that's the probability of failure within 2 years. So the probability of not failing is equal to 1 minus that. So it's 0.80175. And so the probability that we get exactly 1 is equal to 0.19825 for the first one failing and the second one not, plus this. So you can see that this is a very simple example of a binomial problem, right? But in this case, because it's exactly 1 out of 2, you can think of that simply as the bits of a tree diagram. Okay, but you could write a harder question for yourself from this one, that if you had 6 batteries in a really fancy torch, what are the chances that exactly 3 fail within 2 years? Then you're going to be using your Pascal's triangle stuff to figure out how many ways there are here, right? So here we've got the probability of exactly 1 fails. So we're in this row of Pascal's triangle, and that's the number of ways there are. Hopefully that helps. Let me know if it doesn't, and I will try and go a bit more slowly. And email me in question requests, but just remember that I've got reports and debating stuff on at the moment, so it's going to be a wee bit slow getting videos out. Thanks for watching.